So this is a continuation of section 3.5. This is example number 3. In this problem, it is talking about how you can have both direct and inverse variation in a problem at the same time. So if you had this first equation, if I didn't have the z down here, it'd be y equals k times x, that would look exactly like what direct variation looked like in the first example. If I took the x out, you'd have k over z. So instead of having the x in the denominator, we've got a z, but it's varying inversely with z. So you can have it varying both inversely and directly at the same time with two different variables. What does that mean? Well, that means like in a basic equation like this first one, like direct variation did before, if I doubled the x value, the y value would double. But if I doubled the z value, the y value would be cut in half. And so if I did both those at the same time, it basically would negate each other, okay? But what happens if I triple the top one and only double the bottom one? Or what if I triple the top one and I cut the bottom one in half? Okay, so if I did that, it would actually make the y values go up by 6 times as much, okay? Or we could also have not only it varying directly with the variable, but have a variable to some power, and or inversely with something to some power. So that's why I have this example to show you. It has to do with, in this case, a cylindrical column of like concrete. Okay, if you're building like a bridge or something like that, and you have a pillar that you make out of concrete, if you take a pillar and you double its height, it's going to be a much longer pillar, and therefore it's not going to be as strong. Maybe that doesn't seem as intuitive to you, but if you think about like times like maybe you went out in the yard or you were out camping and you were going to build a fire, and you went and grabbed a stick, and you grab a stick and it's pretty much uniform, the thickness of that stick, and then you go to break that stick in half. If it's a pretty long stick and you break it, it's pretty easy to break in half. But then you take one of those pieces, it's the same stick, same thickness pretty much, and you try to break that stick, you'll notice all of a sudden it is harder to break that shorter stick when it's only half the size or half the length of the previous one. So it's half its height, it's harder to break. And then if you take one of those pieces and try to break it, eventually you get down to something that's like, you're like, oh my gosh, I broke this twig when it was a long twig very easily. Now I get this short piece and I can't break it because I don't have enough strength. And it has to do with having enough of a distance of the radius away from the center and being able to get enough torque on it, really, is what that comes down to. Okay? But likewise, you take two sticks that are the same length, and you have one is thicker than the other one, and one that's thicker is probably going to be harder to break, assuming they're from the same tree, same type of wood. So if you change the diameter, that's going to make it stronger. So we're going to look at that in this problem. So I know many times students are like, when am I ever going to use this? Well, I can't get much more into real world math than what I have right here, right now, just talking theoretically. So I'm going to do this problem the same way that I did example number 2, where we're going to go through 4 steps. The same 4 steps I'm going to expect for you to show whenever you do the problem on the test. So the first thing I'm looking at for step 1 is I want to come up with a general equation. So step 1, I just want to come up with a general equation based off of what is being described in this problem. You won't have to write out general equation when you do this. I'm writing out so that you know what I'm planning on doing. So if you just write down step 1 and then write down your equation, that's perfectly fine, okay? But I'm writing down general equations so that you know what I'm calling it, the terminology I'm using. So as I look at this first sentence, it says the maximum load of a cylindrical column of a circular cross section can hold varies directly as the 4th power of the diameter and inversely as the square of the height. And I realize that's a lot of words, okay? But I'm looking for keywords. First of all, it's talking about the maximum load. So I'm just going to abbreviate that just with the letter L. We'll let L represent the maximum load. Now it tells me that it is varying directly and inversely with things. So that means I'm going to have a fraction, and when you write your fraction, put the K on top. Anything that varies directly with the other unknown is going to go on top. Anything that varies inversely will go on bottom. So as I'm looking at this, it says varies directly. So here's what it says varies directly. The very next thing says 4th power of the diameter. So that is what's going to go on top because it's varying directly. So on top, I'm going to put diameter to the 4th power. Then as you read farther into the problem, then it mentions inversely as the square of the height. So that means since that part is inversely, that's what goes in the denominator. So the height goes on bottom, and it says square, so hopefully you know square means second power. If it said cube, then that would be third power. Okay? So you can see which one has a bigger impact on the strength of it. The diameter of the pillar has a bigger impact because it is to the fourth power. The height, not as big of an impact, but it is squared. Okay? So what does that mean? Well, that means like if I double the diameter, that means whatever it is going to be times 2, but now it's to the fourth power. 2 to the fourth power is 16. So that means if you double the diameter, you strengthen it by 16 times as much. If you double the height on the bottom, you cut the strength by a factor of 4 because 2 squared is only 4. So you can see the numerator part, because it's a power of 4, has a much bigger impact on the outcome of the strength or how much this load can handle. Okay, so that's step 1. Step 2, I need to figure out what K is. So step 2, every time we're going to find K. How do you find K? Well, in this problem, I have variables for L, D, and H. That's everything but K. So I should be given some information that tells me what L, D, and H are, like in a scenario. Like in some scenario, this is what the load is, this is what the diameter is, and this is what the height is. And that's what we're given next. It says in the next statement, we've got a column that's 9 feet high, has a diameter of 3 feet, and supports 8 tons. So that is all 3 things other than K. And that's going to allow me then to figure out what K is equal to. So I'm going to take the general equation, and I'm going to put 8 in for L. I've got K times the diameter. I believe the diameter was 3, so that's going to go on top, 3 to the fourth power. And in the denominator, that's the height. The height is 9, so that's going to be 9 squared. And you'll need to solve that for K. This one's pretty darn simple because my numerator comes out to be 81K and my denominator comes out to be 81. So I made this really, really simple because then K comes out to be just 8. Okay? So that's my second step. I found K. K is 8. Now that I know K, I'm going to rewrite my general equation. So, because now I have a value for K, so I call this my specific equation. So step 3, I'm going to write my equation again, but now this time, instead of K, I'm going to have 8 times the diameter to the fourth power over the height squared. That is a specific equation. I didn't write that out, but I call that the specific equation, meaning it is specific to this scenario based off the data that I was given. And so I'll be looking for that. So when I'm grading your test, just kind of give you an idea of the rubric. First thing I'm looking for is, did they write down the correct general equation? Did they make any mistakes? Did they have any wrong powers? Things like that. Because if you, let's say you put it to d to the third power by mistake, but then you find k correctly with d to the third power, so you have the wrong answer, I'm not going to take out points twice for that because I'll see like, okay, they did the rest of the problem correctly, they just wrote down the wrong general equation that threw everything else off. So I'm looking for these little like key points as you go through. So the last thing you'll do is, the fourth step, is you're going to actually take the information that they give you where they ask you a question. They want to know how great a load, so we're looking for the load if it's 12 feet high and 2 feet in diameter. So, but before I do that, let's think about this for a moment. The original one where we got the K value, the column was 9 feet high. Now it's going to be 12 feet high. What's that going to do to the amount that it can handle? It's going to decrease it, right? Because now it's made it longer, it's not going to be as strong. What about the other part? The diameter is going from 3 feet to only 2 feet. So now we've got a smaller diameter, which is also going to make it weaker. So both things are going to make it weaker. So I expect this to be significantly less than 8 tons. All right, because both things, it's like they're not one increasing and one decreasing it. They're both decreasing it. So I'm expecting it to decrease the load that it can handle by quite a bit. So here I've got 8 times, and I've got the diameter is now 2. So 2 to the fourth power. Over the height is now 12, so 12 squared. Now when you put this in your calculator, and you take 8 times 2 to the 4th power, and then you divide it by 12 squared. You just type that in wrong. 12 squared. You're going to get a decimal, all right? But most of your calculators are going to be such that above on my calculator that I'm using right here, which is a TI-30X2S, right above the probability button, so it's catty corner to the second button, there's a button that says F and D. This allows me, if I push second PRB on my calculator and then hit enter, it will change it to a fraction for me. And so if it's a nice exact number instead of a decimal that repeats, you can probably use that feature. This comes out to be 8/9 as an exact fraction, so it's only 8/9 of a ton. So we went from having it being able to hold 8 tons, but because we changed the height and the width to make it weaker in both cases, we ended up only with it being able to handle 8/9 of a ton.